of instruments are available in the market. One is time domain instrument, the other is a frequency domain instrument. So when I say time domain instrument, that means the x-axis represents the time. Basics, if I say, the x-axis will represent the time and the y-axis will represent the amplitude. And in a frequency domain instruments, they have the frequency represent as a x-axis and the power is represented by the y-axis. So why do we need frequency domain and where do we need time domain? So time domain, when I say, so generally we all know the time domain instruments are oscilloscopes, logic analyzers, all those instruments are related to time domain. So it gives you the information. For example, it will give you frequency, peak to peak, voltage, rise time, fall time, turn on of a pulse, off, total turn on and off. All those information will be given, can be measured using oscilloscope. However, what it won't tell you is the frequency composition of that particular signal. So what happens is, if a signal is a collection of sine waves, and when it is combined properly together, it will show you a required time domain signal, and which you see on the oscilloscope. Like example, in sawtooth is a waveform, which you see is a combination of wave signals, right? Similarly, square is a waveform, which is combination of odd harmonics, fundamental plus odd harmonics. So you are not able to see all the frequency components which are available in the signal. For that, what a customer or a user has to do is he has to shift to a frequency domain instrument. So when a frequency domain instrument, I say, that means the x-axis is frequency, and he will be able to see all the frequency which are available in that particular signal. It can have a fundamental signal, then it can have its harmonics. All those can be seen in a frequency domain signal, right? So if I say frequency domain signals are spectrum analyzer, vector network analyzer, all those where the x-axis is represented by the frequency. Uh, so frequency domain signal is better for determining the harmonic content of the signals, which I already told you. Now the question is spectrum analyzer. The definition of spectrum analyzer is a device which examines the spectral composition of an electrical, acoustic, or waveform. That means the spectral composition which is available on that particular signal. It can be electrical, acoustic, or waveform, optical waveforms. Those to analyze that, the instrument is used as spectrum analyzer. Okay. Now there are different types of analyzer in the market. One is, if I can broadly classify it, then we have analog spectrum analyzer and we have digital spectrum analyzer. When I say analog spectrum analyzer, is based on the principle of super deterrent receiver, which is also known as swept receivers, right? So it's use either a variable bandpass filter whose mild frequency automatically tuned through the range of frequencies of which the spectrum is to be measured, or super-determinant receiver where the local oscillator is swept through the range of the frequency. So if a user is working on a particular band, the frequency is swept along that particular band to give the respective phase on the spectrum. In a digital format, what it do is it take the signal, it convert it to A to D, and then converted doing the mathematical calculation of FFT. It transforms the signal into Fourier FFT formats and then into the display in a simple form. So spectrum analyzer. Now the question is, what is spectrum analyzer? So where we know spectrum analyzer? So what is the need of spectrum analyzer? So like I told you before, spectrum analyzer is used to check the harmonics of a signal, right? Different spectral components which are available, the harmonic component which are available in the signals. So for that, you need to use spectrum analyzer. Along with that, if you want to analyze a modulated signal, you want to do the demodulation of a modulated signal or banded signal. At that point of time, you also need to have a spectrum analyzer, because you won't be able to do all those functions using a simple oscilloscope. So spectrum analyzer is mostly involved study of signal entering into a system or producing it, produced by it. Or spectrum analyzer usually display raw unprocessed signal information such as voltage, power, period, waveform, sideband frequency. All those can be measured. And if I talk about the measurement part, it can do band pass filter, ACPR. All those measurements can be done using a spectrum analyzer. Uh, yeah. So like I told you, two basic type of spectrum analyzer. One is FFT, which is fast Fourier FFT based spectrum analyzer. Then we have Swift spectrum analyzer. So in FFT spectrum analyzer, what happened is that time domain signal is taken into is digitized, which is digitally sampled using A to D converter, and then given to and using the processor, it is done. The performance of mathematical calculation is done. FFT calculation is done and converted into a frequency domain, and then get into the display unit. However, in spectrum Swift spectrum analyzer, the most common spectrum analyzer, the Swift tune receiver is there, general purpose tool which convert the frequency domain measurement and technical most used and technique. This technique is particularly mostly used in super heterodyne receivers, which we have used in our life, like the RF receiver, which sorry, the FM transmitter and FM receiver, which are used in the old days, where we need to tune to a particular frequency to listen to a particular channel. Similar function at work. Super heterodyne receiver works. So if I talk about the super heterodyne basic principle, this is theory of operation. You can see this is a basic block diagram of a spectrum analyzer. Uh, so in the simple block diagram, we do have different components. The first is the input signal. Then we have the input attenuator, RF attenuator. Then we have pre-selector, which is low pass filter. That goes to mixer, which is connected to the local oscillator. Then we have IF bandwidth, IF gain, IF filter. We do have a detector, video filter, and then a CRT display unit. We have sweep generator as well to change the local oscillator and simultaneously syncing the CRT display as well. So individually, if I talk about, we use at first we use in a spectrum analyzer there is RF attenuator input, right? So this is for to safeguard the instrument itself. So if by mistake, if sometime user give a higher power signal to the spectrum analyzer to measure the power, so what happen is if you give a higher power, what it do is it might can damage the instrument itself. Okay, to safeguard that, there is a provision of attenuator, input attenuator. What it do is it will attenuate and lower down the power level of the signal, and then it will go through with the rest of the system. If I talk about rest of the system, we do have next we have is a mixer. So the function of mixture is simply it is to change any signal frequency from one to another, one frequency to another frequency. So how I do that is, let's suppose the signal which we are giving is fsig, which is fundamental of signal we are giving, RF signal. Then we are getting a signal from the LO as well, local oscillator. What it do, it mix and give you four components. So four component is addition of the signal and the LO frequency. There will be subtraction of the signal frequency and the LO frequency. There will be signal frequency and LO frequency. So there are four components which are available at the output of the mixture. Out of this four, only we take the subtractions, the subtraction of LO and the signal frequency. Why? Because it's as compared to rest of the frequency, it has a very low frequency compared to that, and we need to have a lower frequency component. The reason to have a lower frequency component after mixture is because for rest of the component which are installed in the spectrum analyzer module, to design those, like for example the filters and the detectors and the amplifiers, it is very easy to design those components at a lower frequency as compared to the higher frequency. Along with that, the other reason why we choose to have the subtracted frequency is subtracted component is because of the use of Nyquistic rule. So where you need to have twice the sampling rate of the frequency, right, to recreate the same signal on the display. So that is the main reason. So by using a notch filter, we only take the LO minus F6, FLO minus F6 only, and that is given to rest of the components. So rest of the component we have IF filter. Sometime you might have heard about RBW as well. This is known as RBW as IF filter. So RBW is nothing but it's a resolution bandwidth. So it's a simple bandwidth which is used to resolute the signal. So what it do is when there is a signal which are very closely together. So if the RBW is big enough to accommodate both So what it do, it will show you as a simple signal, one signal. However, if we reduce the RBW, what it do, it will try to resolute all those signal, and it will increase the sensitivity of the instrument, the accuracy and sensitivity of the instrument when we reduce the RBW. However, because of reduction of the RBW, there will be, as because the size of the bandwidth is reducing, so the time taken to sweep from from starting point to the ending point in a span, it will increase the sweeping strike. So that is the reason the sweeping time will increase once the RBW is reduced. However, the accuracy and the sensitivity of the instrument will increase. So we need to keep that in mind as well during the selection of RBW. Then the block diagram have a detector. The detector has this bins which have either positive detector which take the larger value, either negative detector can be selected as the smallest value in the bin, or it can have a sample detector which take the last value which is available in the bin. So it will show you the last value. It will take the last value on the trace. At last, we do also have video, excuse me, video filter. So what video filter is do, you might have seen in spectrum analyzer, there is a lot of trace noise on the spectrum analyzer when you are looking into or viewing into the signal, right? So to reduce, simply to reduce the video signal, to reduce the trace noise, we use video filter. Once we reduce the video bandwidth, VBW, it will reduce the traces noise which are available on the trace, and will give you a smooth looking trace like this, for example. Okay. Apart from them, these components, we do have local oscillator which give you for the mixture and the sweep generator. Then we have sweep generator which sync between local oscillator and display unit. This is how the front panel kind of look like of a spectrum analyzer. So we have the display, we have soft keys whose function changes with respect to the primary function. So we have primary function to set, like for example, frequency, amplitude, and span. Then we have control functions to change the RBW, VBW, or sweep time, numerical pad to enter the number respectively, and then there is a RF input where the input has to be given through a cable or directly connecting an antenna or something like that, right? This is how the trace look. So if you see, this is a start position, which we call a start frequency. Then we have stop frequency. This whole frequency setup is called as frequency span. Then we have the upper limit is called as the reference level. We do have, and this is into a logarithmic scale. And then we have marker, which is connected here. We also have delta marker. You can see there's one signal over here. There's a small signal over here. This is a table where you can see the frequency and the amplitude of that particular frequency and the delta frequency as well. So this is a representation of the trace which we get in a spectrum analyzer. Okay. So this was a very basic thing about the spectrum analyzer, how we use it, what are the different components. And I talk about the portfolio Anritsu can offer for the spectrum analyzer part. So if I talk about the portfolio, we do have benchtop, we do have Anritsu do have handheld product lines. Then Anritsu also do have USB based spectrum analyzers, or we do have remote spectrum monitors system as well. So let's take one by one. So if I talk about the benchtop models, so we do have MS2830A, which is a combination of signal analyzer, spectrum analyzer, and signal generator. So if a customer who is working on spectrum analyzer only, so he can adopt for this. The starting frequency range starts from 9 kilohertz, goes to 3.6 gigahertz, then 6 gigahertz, 13.5 gigahertz, 26.5, and 3.5. Spectrum analyzer covers all the basic measurement part, which is channel power, occupied bandwidth, ACPR, emission, spectrum emission mass, spurious emission, intermodulation distortion, limit line, peak search, sorry, frequency counter, phase noise, noise figure measurement. All this can be done using the spectrum analyzer. Along with that, it also has the facility of giving the customer of vector signal analysis. For that, So of a customer who is working on modulated signal, or and along with that, vector modulated signals. So for that, he needs to have a system who has an analysis bandwidth. Along with that, he has the instrument should have the capability of demodulating that particular modulated signal, right? So for analysis bandwidth, it has an analysis bandwidth of 10 megahertz base. Then we have 31.25 megahertz, 62.5 megahertz, 125 megahertz analysis bandwidth up to. That is the maximum analysis bandwidth it can have. So it can a user can see a signal with a bandwidth of 125 megahertz in a single display in a same instrument. The multi-domain analysis part is there, where you can see spectrum measurements, power versus time, frequency versus time, phase versus time, statistics, and spectrogram on a single unit segregated, like you see over here. All those can be seen in a single screen. Then it's a compressive analog and digital modulation analysis can be done using the particular instrument. Digitization of AQ data for offline analysis is also available, or signal playback is also available in this. Along with that, it has a USB of having a vector signal generator itself. So it's just not a spectrum analyzer or a signal analyzer. It also has a vector signal generator as an optional along with it. So if a customer who wants to give a signal to a DUT and then see the response from the DUT, this is the best thing, where the user don't have to buy a separate unit or separate signal generator. He can have a single unit which have a signal generator and signal analyzer both in a single unit, as you can see over here. So signal generator, if I talk about the frequency range, it starts from 250 kilohertz, goes to 3.6 gigahertz and 6 gigahertz. The output power is minus 40 to plus 20 dBm. If with the optional, we do have minus 136 as well up to. It's a baseband generator with a vector modulation bandwidth of 120 megahertz. That means your customer can generate a vector modulated signal with 120 hertz of megawatt bandwidth, with a sampling clock of 20 kilohertz to 160 megahertz, and a memory of 64 megasamples, right? And the accuracy, if I talk, it's plus minus 0.5 dBm. It's an integrated AWG generator. BR measurement, which is BR measurement, this function is available with it. Along with that, play by signal capture via vector signal analyzer option is there. That means if you have a real environment signal, you can capture that using a vector signal analyzer. You can recreate it and playback through and generate the same signal which you capture in the environment through a signal generator, same signal generator. So the advantages, if I talk about 2830A, so it's a spectrum analyzer plus vector signal generator plus vector signal analyzer. All three instruments in a single instrument. It's a very high speed instrument, so it can goes from 10,000 point sweep per millisecond. The dynamic range is very good. It has a dynamic range of 168 dB. If I talk about the display average noise level, DNL, which is minus 153 dBm per hertz. Third order intercept is plus 15. Accuracy, if I talk about of the receiver, it's 0.3 dB typical. Bestest class phase noise it has of minus 118 dBc at 10 kilohertz. Along with that, it's a very low cost effective instrument, if I say. Then we have the other model we have for the benchtop itself is MS269XA 9 series A. Again, it's a combination of signal analyzer, spectrum analyzer, and signal generator. Frequency 6 gigahertz, 13.5, 26.5 gigahertz. If I talk about the measurement, it covers all the measurement which we talked in 2830. Vector signal generator option is there, and the analysis part, we do have analysis bandwidth of 31.25 megahertz, 62.5 megahertz, 125 megahertz. Again, it can cover multi-domain analysis, which have spectrum measurement, power versus time, frequency versus time, phase versus time. Spectrogram is there. It can digitize the IQ data for offline analysis. Signal playback is there. The best part about this instrument is it has a streaming up to 4 hours of 20 megahertz bandwidth signal into eSATA drive. It can stream directly without any loss of data. Along with that, it also again has a vector signal generator up to 6 gigahertz, starting from 125 megahertz. Output power is minus 140 to plus 10 dBm for continuous wave, and for modulated 0 dBm. Baseband generator, we have 120 megahertz. Sampling clock again 20 kilohertz to 160 megahertz. Memory, it has a higher memory as compared to uh, it has higher memory as compared to the other model. We have the memory is 256 millisample. Again, the playback signal capture via vector signal option is there. So you can capture any signal and you can play back it, or you can generate the same signal using the generator output. Advantage, if I talk all three instrument in single one. So depending on the customer requirement, he can have either spectrum analyzer, or he wants to have generator as well along with the spectrum analyzer or signal analyzer. He can order that. It's very top class performance at the mid-range price. If I talk about the dynamic range, it has a very good dynamic range of 177 dB. DNL is minus 155 dBc, dBm per hertz. TOI, if I talk about plus 22 dBm. Accuracy is again 0.3 dB at 50 hertz to 6 gigahertz. It's based in window-based spectrum analyzer is there. So right now it's based in 7 and Windows 10. So it's very fast for new PC as well. Again, the best part is streaming up to 4 hours of 20 megahertz wideband signal into a disk, which is good. Then again, the other model for the benchtop, we do have 28408. The frequency range is 3.6 gigahertz, 6, 25, 26.5, and 45 gigahertz up to 45 gigahertz. Start from 9 kilohertz. Have available measurements are already there, which I talked earlier. It's the same measurements. We have signal analyzer option as well in the same, up to the analysis bandwidth of 125 megahertz. Same multi-domain analysis options are already there, and the vector signal analyzer. Again, compressive analog and digital measurement are there, and modulation measurements are there. Digital IQ data for offline analysis and signal playback is there. Again, we do have signal generator, which goes from 3.6 gigahertz and 6 gigahertz model, starting from 256. Same, this specs is similar to what we just saw. So I'm going to escape that. The advantage, if I say again, it's a single instrument with having signal generator, spectralizer, vector signal generator with a high dynamic range of 168, and average noise level is minus 153 dBm, and the accuracy is again 0.3 dB typical. Now this was the portfolio for the handle formats. Sorry, the benchtop spectrum analyzer what Anritsu offer. Now we are talking about the handle spectrum analyzer what Anritsu again offer. We do have signal analyzer for handle. We do have spectrum analyzer for handle as well, along with the tracking generator. So this is the T series, we call it. It's MS2720T. It's a battery operated instrument. Starting frequency starts from 9 kilohertz. Then model are 9 gigahertz, 13 gigahertz, 20, 32, and 43 gigahertz. Available measurement, if you see, we do have field strength, channel power, occupied bandwidth, ACP, a carrier to interference ratio, emission mask, AM, FM, SSB demodulation is already there with the built-in speaker and headset is there to analyze those signals. Then we have spur emission is there, save on event option is there, buzz detect, limit line, peak search, 1 millihertz resolution frequency counter is already available in this. So although it's a handheld product, but if you see the performance of this particular instrument and compare it with the benchtop, you see it's as comparable to the benchtop. If I talk about the highlights, the measurement part, it has the measurement for interference, spectrogram, signal strength, receive signal strength indicator is there. Then it's a touch screen based 8.4 inch TFT display is there. It can be connected to the PC or network using Ethernet or USB is there. Then dynamic range, if I say it has a dynamic range of 106 dB at 1 hertz, which is good. And if you see the DNL, which is minus 164, is as comparable to a benchtop. Resolution bandwidth, it has a resolution bandwidth of 1 hertz to 10 megahertz. That means if a signal which are 1 hertz closer to each other, he will be able to resolute that as well. It also has a tracking generator option. So if a customer who wants to have a spectrum analyzer and want to do some component testing, like attenuator filters testing or antenna testing, he can go for tracking generator instead of going for a vector network analyzer. He can have a tracking generator. He can do all those measurements. Sorry. Preamplifier is standard in his in this particular model. Then we have channel scanner option is there. Coverage mapping is there for to plot an RSSI on a screen. Interference map can be loaded on this. It's a battery operated. It will give you a time period of 3 hours of on tracking measurements. It's operating no, this particular instrument defined for military standards. It's compliant to the military grades, the melt standards compliant, so it can work in the plus 55 degrees Celsius as well. Along with that, has a capability, like I said, it has a capability of signal analyzer as well. So it has a 20 megahertz of analysis bandwidth, which is optional wireless measurement. So it can do wireless measurement like GSM, WCDMA, LTE Advanced, FDD, TDD, LTE 256 QAM, DMODs, NB-IoT can be done, CDMA can be done. So all those parameters can be used using this analysis options. It can capture IQ data, IQ waveform. It also has a gated sweep, FM, PM, AM demodulation option is there available. Along with that, a user can connect high accuracy USB-based power sensor with the instrument, and he can use the display of the instrument to measure. And there is no limitation on the bandwidth, so you can use any power sensor, USB-based power sensor using the particular instrument, and goes up to 26 gigahertz. It has 3-hour battery life, already talked about. GPS receiver is already there in this particular model. These instruments are there with a similar feature of what we talked in the T series. So BTS master goes to 7.1 gigahertz. It has cable antenna analyzer, power meter, vector signal generator, and signal analyzer all together in a single instrument. Then VNA master, which I talked yesterday, it has a VNA plus spectrum analyzer. It uses the same PCB of the T series, same spectrum analyzer, but it has a VNA itself with all 4 parameter, 2-port VNA, full 2-port VNA. Then these are the starting handheld spectrum analyzers. We have starting with 3 gigahertz, starting with 9 kilohertz to 3 gigahertz, then 4 gigahertz and 6 gigahertz. MS2711E, 12E, 13E. It has a 1-button measurement of ACPH, channel power, field strength, occupied bandwidth, AM, FM, SSB, DMOD. It also has option of interference analysis. So customer who is working on interference, he can go for that. He can go for interference mapping, spectrogram, signal strength, RSSI, and signal ID as well. It also has the option of coverage mapping, indoor, outdoor, both. If a customer wants to do indoor mapping, he can do. If I talk about the specs, the DNL is minus 152 dBm per 100 hertz. Dynamic range is 102 at 1 hertz for MS2712E and 13E. Phase noise, if you see, is minus 90 dBc per hertz and minus 100 dBc per hertz for at 100 kilohertz offset. Frequency accuracy, if I talk about the frequency accuracy, it's in parts per million, which is 1.5 parts per million. However, for 12E and 13E, it's 50 ppb, parts per billion, which is very high on GPS. Detection mode, it has peak, negative, sample, quasi-peak, true RMS, all this detector are already there. If I talk about the options which it has analyzer, interference option is there. GPS receiver, bias T is already there. Power meter can be connected. Channel scanner option is there. Tracking generator option is there. Gated sweep option is there. EMF measurement can be done with the help of this. Preamplifier option is also there. And this is particular rest for rest of the instruments. It's vast standard. For MS271311E, it's a optional part, preamplifier. And if I talk about the measurement, it also has 20 megahertz of bandwidth, coverage mapping, AM, FM, PM analyzer, LTE demod, STMA demod is there, CDMA, fixed narrowband IoT analyzer is there. So these are the demod options available. If a customer is looking for over-the-air demod application, you can go for that. These instrument has same feature of that what we talked in MS2711E, 12E, and 13E. So 4 gigahertz, 6 gigahertz. We have VNA master, we have side master, we have LMR master, which goes up to 6 gigahertz with a combination of VNA, power meter, CW signal generator, NBFM analyzer. Then we have cell master, which is a combination of spectrum analyzer and cable antenna analyzer and signal generator, CW signal generator. Then this is a very interesting product, which is ultra portable spectrum analyzer. We call it Spectrum Master Ultra Portable Spectrum Analyzer. So it's a very handy product. So if you see the sign and the form factor is similar to what we have a USB hard drive. However, if you see the specification, it can go up to 170 gigahertz. Yes, that's right. This receiver starts from 9 kilohertz and goes up to 170 gigahertz. So you don't have to have a very bulky instrument for this to go up to 170 gigahertz. It can do in a single sweep without any breakage in the frequency band. So it starts from 9 kilohertz, goes to 32 gigahertz, 44, 50, 70, 90, 110, 145, and 70 gigahertz in a single instrument. This is just the size of a hard drive, and it's powered through a USB itself. You don't have to put an external power supply to it. It directly take power from the USB, which is connected to a laptop or a tablet, window-based tablet, and you can connect it, and user can do the measurement using it. We have two model, which is MS2760A and 2762A. 6 to 8 start from 6 gigahertz. Rest of the model are same. Just it start from 6 gigahertz instead of starting from 9 kilohertz. If I talk about the measurement, what it can do, it's a simple spectrum analyzer. It can do rest of the measurement which we talked, like channel power, occupied bandwidth, adjustment channel power ratio, spectrum and spectrogram display is also there. If I talk key features, first is the form factor. It's very small as compared to what we get in the industry. If I talk about 110 gigahertz or 145 gigahertz spectrum analyzer, it will be huge, bulky spectrum analyzer will be there. Along with that, the resolution bandwidth starts from 1 hertz, goes to 3 megahertz. Phase noise is good. It's minus 116 dBc per hertz. You can have multiple traces and a single display. Detectors are there. 12 marker, you can have dynamic range is greater than 108 dB for 70 gigahertz at 70 gigahertz for MS2762A. So if you see the spec, it's good. So as you can see, this is display of this is a window-based tablet. So this is directly connected through a USB cable through it. It's powering through the USB itself. You don't need to have an external cable for it. It's a very strong factor, and it's based on FFT analyzer base. And Anritsu has this patented technology on non-linear transmission line technology, because of which Anritsu actually able to confine this instrument into a very small form factor. Start from, like I said, 9 kilohertz, goes to 170 gigahertz. For 170 gigahertz, we are using 0.8 coaxial connectors. The frequency bands are 32, 44, 50, 70, 90, 110, 145, 170 gigahertz models. If I talk about the amplitude accuracy is 0.5 dB, which is good. It has a very fast sweeping speed. It's a single sweep speed, right? Single sweeping up to 170. And dynamic range is 103 dB at 70 gigahertz. For MS2762A, again, everything is same, just start from 6 gigahertz. And if I talk about the dynamic range, it has an improved dynamic range of 108 dB as compared to MS2760A. This is a GUI. If you see the GUI, it's a very user friendly, and it's touch based as well. Then we have Field Master Pro, which is again a Handheld product, is new in the family. If you see, this is a Hall touch-based scheme. This is designed for 5G measurement and LTE measurement. So frequency range, it has best-in-class frequency range, DNL, TOI, and amplitude accuracy. If I talk about the frequency range, it starts with 9 kilohertz, goes to 9, 14, 20, 26.5, 32, and 43.5 gigahertz. And the last model, which is the highest model, is 54 gigahertz in a single sweep. No gap is there, no missing is there, right? TOI, it's plus 20. DNL, again, it's minus 164. Phase noise is 106, minus 106 dBc. RBW is 1 hertz to 10 megahertz. It has a detector of average, RSM, peak, negative. It's a battery operated. It can be connected to the Ether or USB 3.0. It can have a function of, it also has an RTSA for 110 megahertz. So it also come up with 110 megahertz of RTSA, which if a customer have a very minimum signal of nanoseconds, he will be able to capture using this particular instrument. 5G analysis option is there. So it can connect directly to a direct antenna. It has the application of 5G DMOD. NR application is there to analyze the SSB and GSEN of the 5G measurements. So I'm not going to cover this just for the time's sake. It also has other applications like gated sweep, channel power, occupied bandwidth, spectrum mask, spurious mask. It can also capture, as it has a bandwidth analysis bandwidth 100 megahertz. It can capture up to IQ data and stream it as well. So it has 2 GB of RAM. So it can directly continuously capture the IQ data, and it can transfer to a stream to a PC or USB or SSD directly. This is a very good option in this. It can directly connect it to the Wi-Fi for remote access. So anybody can access if it's connected to the respective Wi-Fi. Then Spectrum Monitor is there. So Spectrum Monitor is a customer who is looking for 24-hour into 24-hour into 7 into 365 days of monitoring. So they can adopt for that. These instruments are there to run all day long without any problem. You can store the data, and if customer wants multi-port spectrum analyzer, they can adopt for MS27103A, which give you facility of 12 ports or 24 ports. Now this is 12. This is not a 12-port spectrum analyzer. The hardware is one. It's the same single hardware is there for the spectrum analyzer. However, there is a mixer, which is switcher is there, which is a high-speed switcher, which switch from one port to 12 port very fast. Then we have single port as well. We have up to 6 port, 1, 2, and 6 port with a unit which can be mounted outside in an outer environment. Then we have PCB model as well for monitoring purpose. So again, goes up to the particular model for MS2710A series. It can start from 9 kilohertz, goes to 6 gigahertz of frequency coverage. Very fast sweep, 24 gigahertz per second. Dynamic range is again 106. Connected to Ethernet. This is how it looks. Thank you. Now I guess Anup will take over this particular presentation, rest of the presentation. Anup.
Thank you, Aditya.
Thank you.
So Anup, shall I make you presenter, or you will be using the same slides?
No, sir. Please make me a presenter.
Okay. So now you are presenter. You can just go ahead.
Good evening, all. My name is Analyser, and again, I'm going to give my introduction. I'm a part of technical support team based out of Noida. So today, I'm going to present a small presentation on Anritsu signal generation. So,
Anup, your voice is not audible. You please come closer to your speaker.
yes, now I'm audible, sir.
Yes. Now it is better.
Yeah. That's because of ceiling fan. So now I'm starting my presentation. Now it's clear? Or someone saying audio is
Yes,
not
yes,
clear.
it is clear. You can go ahead now.
Yeah. Okay. Yeah, so this is the agenda for today's presentation. First, we'll start with the application of signal generator, then the typical architecture for signal generator, which covers like block diagram. In block diagram, it will cover reference, circuitry synthesis, how we synthesize the signal output, and then modulation. Then portfolio available with the Anritsu, what all signal generator are available with Anritsu. So without wasting your time, I'm starting my main presentation. So what all instruments is required to measure wide range of parameter or for wide range of application. Like if you want to measure a power of any RF signal, you require a power meter. And if you want to measure a frequency, then you require a frequency counter. For time domain analysis, you require oscilloscope. For frequency domain analysis, you require a spectrum analyzer. Then for characterizing any RF devices such as passive or active like antennas, filters, or amplifiers, you require a scalar or a vector network analyzer. Then comes a signal generator for response of stimulus. So um, signal generator have a very wide range of application for research, for production of any RF instruments or receivers or oscillators, then for field users as well. So traditional application for signal generator are component characterization, and it is also used for LO substitution, like you doing a mixer measurement, then required a local oscillator. So LO substitution, as you can use your signal generator as a allo substitution as well. Then scenario simulation or emulation of your any signals with the help of signal generator. So, so using pulse for the radar simulation, you can use or you can produce a pulse signal with the help of signal generator in 1 to 4 pulses with independent pulse width or with independent delay. This will help you to replicate radar simulation or emulation. And then another application is testing of TR modules in radar application. You want to generate RF signal or you want to generate IF signal, you can generate with the help of signal generator, and you can you can feed to your TR module and check the response. Then another application in general purpose is testing of communication transmitters or receiver, or we can say base stations or base station for 4G or 5G. So you can generate your RF signal, you can generate IF signal, again you can generate baseband signal with interference of any kind of interference which occurs due to multipath or some other factor. So you can replicate with the real time with the help of signal generator and test your BTS or your node Bs. Then another application is multi-source application, while like you doing a intermod IMD measurement or passive intermod measurement, you require two tones. You can generate with the help of signal generator, and in a multi-source application, there is another application for phased array antenna. If you are designing any phased array antenna, you want to stereo beam, then it's required signal with different phases. So you can generate with the help of signal generator. So this is for multi-source application. And this slide gives you what all key figures or specification value signal generator. In a signal, you have to consider frequency range, amplitude accuracy, frequency accuracy, resolution, and the switching speed. Apart from this, you have to consider the spectral purity, how my signal generator signal is pure. You can check with the specification like phase noise, spur, or harmonic. So spectral purity is a very critical parameter value selecting um, signal generator, and VSW are for overall system. So if you're saying that this is your main signal or CW output, you can check your phase noise at particular offset,
with the spec sheet given in a particular make or model. Then subharmonics you can check non-harmonic spur, you can check the harmonic spur. So this is the very critical parameter while you selecting signal generator. So this is a basic block diagram or block diagram for signal generator, uh, where it consists reference, it consists synthesizer, where your signal is synthesizing, and your modulation, how you modulating your signal with the help of LF generator, internal LF generator. Uh, we have a capability to generate a modulating signal internally, or you can generate externally and give to the signal generator. Then this whole circuitry is for 2 to like 20 gigahertz, 40 gigahertz, or 61 gigahertz or more than that. So if you required a signal which is below than 2 gigahertz, then we are using this down converter circuitry. This is started from 8 megahertz and goes to 2 gigahertz. So things to remember, this is uh, for starting for 2 gigahertz, and if you want to generate a signal, our signal generator goes to this circuitry. This is a down converter, and the frequency started for this down converter is from 8 megahertz to 2 gigahertz. And further you want to down convert your signal, or you want to generate from like 0.1 hertz, which is close to DC, you can generate with the help of this DDS circuitry. So we are our signal generator is capable of generating signal from 0.1 hertz, and which can all they go up to 67 gigahertz with the help of this block diagram. So I am discussing about this reference. This is a key contribution, like what all factor or specification are considering, like aging rate, temperature. So internal time base of the signal generatability, it depends on the aging and with the temperature. So this is the specification for our signal generator. You can check for our signal generator, we are giving 2 into 10 to the power minus 9 per day aging rate, and this is with the temperature. And if we considering about the spectral purity, phase noise for our OCXO means open control crystal oscillator. So this is the very fine specification for OCXO. So there are different type of crystal oscillator. So, some of like voltage control, some of like temperature control, or some of open control crystal oscillators. So, and if we going about synthesis having a different type of techniques. First one is direct, second one is indirect. Indirect, there are two types, analog and digital. Indirect, there are two types again, single loop and the multi loop. We are using hybrid type, which is a combination of indirect and direct method. So when you synthesizing your signal with the help of direct, indirect, you like using analog method, it's required, it's using an individual filter for individual frequency band. So advantage for direct analog method is fast switching and low phase noise. Disadvantage is many component, and it's bulky and less reliable and expensive because we are using many components. So and then spur is better than the digital one, but it's still poor. Then this is a digital method. The advantage for using a digital method for synthesizing your signal, very fast in switching, very fine resolution. Then disadvantage is very limited bandwidth. So it can go up to like for few megahertz or few gigahertz only. And it has a very high spurious content at a lower frequency. So this is the disadvantage. And then this indirect method, there are two types, single loop and the multi loop. So in single loop, there are some hardware are available. It's yttrium iron garnet oscillators, which gives you very good spectral purity, but slower as compared to other technology. It's expensive, and it's required huge power to generate your RF signal, and it is bulky in nature. if you're using a voltage controlled, then again slower, but the cost is lower as compared to YTO, and it's smaller in size. So this is a hybrid one. We are using a hybrid one where you can see like digital down converter. It's using a different like VCOs. It's using PM oscillators. So we are using a hybrid technique to synthesize a signal. So this is again same slide which gives you like spectral POT. You can check this is a CW. You can check a phase noise and spec sheet, non-harmonic spur, sub-harmonic spur, and the harmonic spur. With the help of this slides, you can see. Then when you selecting any signal generator, you have to watch these area like phase noise of the signal generator, harmonics, non-harmonics. In harmonics, you can check what is the second harmonics, third harmonics, and the fourth harmonics. Then the non-harmonics, you can check at what frequency it's generating harmonics. Then spurious, then settling time, then the accuracy and the stability. So this is the main points or area to watch when you're selecting signal generator. So there are mainly two types of signal generator are available. First one is analog one, and second one is a digital one. Analog signal generator can generate your analog modulated signal or FM or phase or pulse modulated signal. With the help of digital or vector signal generator, you can generate your digitally modulated signal or complex modulation like BPSK signal or like QAM signal, 256 QAM signal. All digital modulated signal can be generated with the help of VSG. So this slide gives you a comparison between the different type of modulation scheme. First one is a CW signal. Then second one is a amplitude modulation where you can clearly see the amplitude of the waveform is varying. And third one is a phase modulation. You can see the phase of the waveform is different as compared to this one. Then this one is a frequency modulation. Then this one is your pulse modulation. So this slide gives you a comparison of the modulation type. Then this equation is maybe you known to this equation. With the help of this equation, we can generate analog by varying this. We can generate amplitude modulated or pulse modulated signal. By varying this component, we can generate frequency modulated or phase modulation signal. So this is the brief about amplitude modulation. Important characteristics for amplitude modulation like modulation frequency rate, depth of the modulation, linear amplitude modulation percentage, log amplitude modulation, sensitivity, and the distortion in percentage. Where amplitude modulated signal is used in AM radios, antenna scan or ASK. Sorry. So this slide gives you like brief idea about the frequency modulation. This is a voltage, this is a time, and important characteristics of the frequency modulation like frequency deviation, modulation frequency, accuracy, resolution, distortion, and the sensitivity. Where FM modulation or signals are used in FM radios, aviation, flight system, in radar, in FSK, again in digital. Then this is the equation for frequency modulation. This is a phase modulation where phase deviation is an important characteristic. Modulation rate, accuracy, distortion, sensitivity again, where phase modulation or signal are used in PSK for early digital 1010 format, in radar for pulse coding. For pulse modulation, of course, this is for radar and high power stimulus response. And then important characteristics for pulse modulation are like pulse width, pulse period, on-off ratio, and the rise time. So this is the important characteristics for pulse modulation. This is for digital modulation characteristics. BPSK, QPSK, and the QAM signal we can generate with the help of vector signal generator. So this is the constellation diagram. for BPSK signal, you can see this for 10, and this one is for QPSK signal in 01 and 00 format, and this one is for 16 QAM. You can generate your 256 QAM, 64 QAM, any of your digitally modulated signal. So this is actual signal generator. Looks like this is a full hardware for signal generator. This is a microprocessor for processing all unit. This is a switch filters. This is a level coupler. This is yttrium oscillator. This is ALC. This is for power supply. This is a basic building block for signal generator. So, forward to portfolio available with Anritsu. So we have a couple of signal generator available with us. First one is analog signal generator, and then second one is a vector signal generator. You see this MG369X series is analog signal generator. The starting frequency range is started from 0.1 Hertz and it can go up to 67 gigahertz. Then we have some millimeter wave extender, which we can further extend this 67 gigahertz to 500 gigahertz. So same system can be upgradable to 500 gigahertz frequency range. Then we have this analog signal generator with dual output. It can go up to 6 gigahertz from 100 kilohertz. So simultaneously you can generate both signal with the help of dual output option. Then we have a vector signal generator for generating your digital modulated signal. The frequency ranges remain same, and again this is dual output. This analog signal generator comes from our US factory, and this comes from our Japan factory. So the frequency, again I'm saying, we can go up to 500 gigahertz with the help of this signal generator. For this one, we can go up to 6 gigahertz for analog signal generation. We can generate a digitally modulated signal with this one as well, but the bandwidth is limited with this model. With this one, we can generate your LT signal. You can generate your 5G signal as well with the help of this vector signal generator. So for FR1 or sub 6 gigahertz 5G generation, we can use this MG3710E. Then we have some combinational boxes with Analyser plus signal generator. So this is MS2038, which comes with a signal analyzer option and with signal generator optional. And this one, again, another model, again same with inbuilt signal generator and a signal analyzer. The advantage for one box solution, it will take less space on your bench. You can generate simultaneously with signal generator and measure at a signal analyzer. You can capture your signal with the help of signal analyzer and regenerate with the help of signal generator. So this is a full-fledged spectrum analyzer or signal analyzer, means you can demodulate your analog and digital modulated signal with the help of the signal analyzer, and same time you can generate with the help of this signal generator. The frequency for this signal generator is limited to 6 gigahertz, and for the signal analyzer it can go up to 13.5 gigahertz. And for this one, again same, it started from 50 hertz and goes to 13.5 gigahertz. The frequency range for the vector signal generator is 125 megahertz to 6 gigahertz. So this is the some key specification for analog signal generator. Again, I'm saying this is starting from 1.1, which is close to DC, and we can go up to 70 gigahertz, and beyond that we can go up to 500 megahertz. It has industry best phase noise. It will give you minus 60 dBc for across the frequency range. Full analog modulation and high output power option available. Analog modulation means you can generate your analog modulated signal, your AM signal, FM signal, phase or pulse signal. Fast switching speed, industry best pulse modulation with the pulse width of around 0.7 nanosecond. Then characterizing your, then you can characterize your receiver with the help of the signal generator. This is the frequency options. So We have 20 gigahertz model, to 40 gigahertz, 50, and the 67 gigahertz. So this one is our analog signal generator from Japan. It is for 6 gigahertz only. Main advantage is output level. You can generate up to 23 dBm signal with the help of the signal generator. You can generate 2 signal for IMD testing. It has a dual output for independent RF output. Then frequency option available with us is 2.74 and 6 gigahertz. So again, this vector signal generator, same dual output with high purity signal source. You can generate dual output. It has a built-in AM/FM phase and pulse modulation function. You can generate your digital modulated signal as well. It also has the same 2 RF output using dual RF output option. The frequency range for this one is again 2.74 and 6 gigahertz. So that's all from my side for signal generator. Now I'm handing over to Mr. Lakshminarayan. If you have any question regarding my presentation, please feel free to express yourself in chat section. Thank you.
Yeah, so Lakshminarayan, you will be making your own slides. Shall I make you
Yes.
presenter?
Yes, sir. I am using my own slides.
Okay, now you are presenter.
So, good evening, everyone. So, we have come across the previous spectrum analyzer basics and signal generator basics with the portfolios. So, now we will be going on to power measurement. So, what is the power measurement? And in this presentation, we will be coming to what is the power measurement, why we need to do it, and test applications, where the power meters are used, and sensor technology, quick look up on the portfolio, and key features of power meter portfolio, and various standalone USB power sensors and frequency selectable millimeter wave power analyzer. So what is the signal power levels are very critical. As we know, the measurement of the signal level is critical at every system level, from the overall system performance to the fundamental devices. In a system, each component in a signal chain must receive the power signal level from the previous component in the system and pass the proper signal level to the other succeeding component. If the output signal level becomes too low, the signal becomes obscured in the noise signal. If the signal level becomes too high, the performance will be non-linear and distortion will result. Even if the worse, the damage will occur in the device. So the important power measurements are measurements like critical to specified performance at every level of a system. It is very difficult. Many measurements made in the designs and measurements. For testing this power measuring equipment, the techniques must be used should be accurate, repeatable, traceable, and convenient. So why not measure a voltage? Because we are talking about the power measurement, we can do in the voltage also. Why not we were using a voltage? At the DC or low frequencies, voltage measurements are simple and straightforward. If power is needed, it is easily calculated by P is equal to VIV is equal to V square by R is equal to I square R. However, as the frequency approaches 1 gigahertz, direct power measurement becomes prevalent in most applications. Voltage and current measurement becomes impractical. One reason for this is that voltage and current may vary with a position along with the lossless transmission line, but power maintains a constant value. For this reason, after microwave and radio frequency, power is more easily measured, easier to understand, and more useful than voltage or current as a fundamental quantities. So what is the units and definitions of the power? Power is a energy transferred power per unit time. Basic power unit is watt. 1 watt is equal to, as we know, 1 watt is equal to 1 amps into 1 volts. The logarithmic decibel scale is often used to compare two power levels. When you come to when you are doing the power relative power measurements, you will be comparing the two power levels by 10 log by P2 by P1. When you come for absolute power, it is expressed as assigning taking a 1 millivolt as a reference with a P1. So P power dBm is equal to 10 log P by 1 millivolt with reference to 1 millivolt. So this is a table where you can see the dBm and watts. So 0 dBm is equal to 1 milliwatt, 10 is 10 milliwatt, and 20 you will get 100 milliwatt. When we convert from dBm is equal to 10 log P by 1 milliwatt with reference to 1 milliwatt. So test applications example where power meters are used. It is used in from 3 kilohertz to 300 gigahertz. Power measuring the most of fundamental measurements for performance verification in regulation bodies, in safety and security efficiency, and other applications also. And to avoid the physical harm in the power, whenever you are using a mobile, if there is a high power, it may damage your brain. So it will physically cause harm. And in the circuit damage, it may, if there is a high power, it may damage the circuit board. Or if you are using a broadcasting or a mobile communication, if there is any interference, the power is the cause of that. So next, common applications includes the power calibrations also. In VNA signal generators, we use a calibration purpose. We will use a power meters and power sensors. In calibration labs, as a standard, we will be using a power sensor and calibration, power sensor and power meters for signal profiling and on-off testing in a manufacturing, in characterizing modulated signals like radar applications and aerospace and defense applications. We will be using the power meter for average power reading for a CW signal, nothing but oscillators and other things. So sensor technology, what is the technology it is used in the sensors? Commonly, we use a thermal sensor or a diode sensor versus diode sensor. Thermal sensors. So thermal sensors, there are two types. One is a thermistor sensors, usually based on a Wheatstone bit. One bridge element is a thermistor. RF energy is applied to the thermistor. Depending on the heating, the resistance will be changed. And the DC power is delivered to maintain the bridge balance. The change decrease in DC power is equal to the power applied. And next is the thermocouple sensor, where we will be using a two dissimilar joined together at one point. That is nothing but two junctions will be joined at one point where the temperature change, when the voltage is applied to that junctions, the temperature changes. Depending on the temperature changing, we'll get the value of the voltage applied. This technology is used in our Anritsu MA2830A series sensors also. So next is diode sensors. Diode characteristics change at different power levels. There is a different regions. It operates in different regions. That is a square law region, transition region, and linear region. In a square law region, the DC output is proportionally varies to the square of the applied RF voltage, and it is most often used for a modulation independent. And linear region, where the DC output voltage is proportionally to the peak of the RF voltage, and peak envelope detection, where we will do the peak envelope detection. And transition region is the accurate reading depending on the characteristics of the power. So there is a diode sensors. Depending on the which do you use, depends on the what are the measurements you want to do. You can select the diode sensors. So if you are using if you want to measure a CW signal, you can use a CW average power sensor, which is good for a power calibration and most commonly purchased for a pin stop sensors. And if you are using for a modulation signals, you can use a 2 or 3 true RMS power sensors, which is modulation independent across entire power range, which will be used for most of the modulation applications. And you can use for a pulse measurement, you can use a pulse power sensor, which is having a wide band sensor with a very high bandwidth, video bandwidth, and limited power range plus 20 to somewhere around minus 20 or minus 30. And the advantages of this diode sensors is wider power range, faster settling time, and disadvantage depending on the sensor sensing element, it may damage when there is a high power, and the accuracy, it will be little bit difficult to get a more accuracy in the diode sensors. So usually we use a thermistors for a high accuracy in measurements, in the power measurement. In the case of a radar application or a pulse modulated signal, there is a different terms and different powers which we will be measuring, which will be come to know. So like when there is a instantaneous power, the first term instantaneous power is the actual power where power of the signal at any given time. It is the instantaneous power where the first term it will be instantaneously the power it will come. In most cases, when you some capturing instantaneous power requires an instrumentation that can react fast enough to capture the rapid changes in the signal. Most power meter sensors are not fast enough to capture this instantaneous signal. So we need high digitized oscilloscopes and high-speed digitizers for this. In most cases, when someone is referring to peak power measurement, they are referring to the peak envelope power, not the peak instantaneous power. So for instantaneous power, we needed the oscilloscope, and there is a envelope power, PET, which is represented by blue line, is the amplitude change due to the modulation, and is another measurement as the function of time. So the peak envelope power is the highest signal power measurement from within the envelope power reading, what we will be reading in the power sensors. The burst average power simply is the average power from the within the just the burst. At last, the power average is which is the average power taken over a specified period of time. So this is the average power, and it is color coded with the different colors. So some of the common questions when you are dealing with the power meters or power sensors. What is the measurement uncertainty? Usually these questions arises measurement uncertainty and what is the bandwidth, video bandwidth of the sensor? Why use the USB power sensor instead of a benchtop? This is the common questions when we talk about the power meters or power sensors. Measurement uncertainty. There are different parameters or contributors for a measurement uncertainty. One is the mismatch uncertainty, which is the mismatch between the oscillator, 50 ohms oscillator, reference oscillator, and the sensor. So which can be calculated easily, and we can come to the mismatch uncertainty. And there is one more noise contributor where the most commonly concerned about two low power levels can be minimized by using a averaging in the power meter. And zero set and drift contribution can be minimized by giving a warm-up time to the power sensor or oscillator after around 60 to 30 minutes. After this, we can set a zero set or drift. We can minimize the zero set or a drift. And if you are regularly zeroing the power sensor, you can do the zero set or a drift. There is a cal factor uncertainty which is available in the data sheet. And the reference power uncertainty is nothing but the oscillator reference uncertainty, which is in the benchtop meters, not for a USB power sensors. So these are the measurement uncertainty parameters or a contributors. So what is video bandwidth? A critical power for a peak sensor to accurately measure is a modulated signals. Video bandwidth defines how well the power meter can capture the peaks of the modulated waveform. So this is the whatever the red color is the video bandwidth. The signal, what is in the blue color is the pulse power, the peak power. So if it is falls within the video bandwidth, within the video bandwidth, we can measure the pulse modulated signals. So video bandwidth can be calculated as video bandwidth is equal to 0.35 by rise time of the circuit detection. Okay. So what is the power meter portfolio? We are having a portfolio of ML2490A and 2430A. The 2430A is a CW applications and combination of accuracy, speed, and flexibility in a low-cost price range. And 2490A it is used for a pulse power measurements and a modulation signals measurements. And we are having 7 different families of power sensors, including USB power sensors. Depending on the application, we can select the power sensors. So 2490A pulse power meter has a high performance and precision because of its highest video bandwidth of 65 megahertz and 8 nanosecond of rise time. in a precise race time measurements of radar signals and 4G OFDM signals. And it is having high speed sampling up to 1 giga samples per second, which will be very useful for a wireless mobile modulating signal measuring. And there is a triggering option where you can use an internal or external triggering to capture the signal, pulse signal. And there is some of the measurement gates and markers up to, there are different marker gates and measurement gates and markers with the 4 independent gates to measure the minimum, maximum, and average power sensors and other applications where you can use for a race time and fall time of a pulse also using a measurement gates. So we are having external video for a VGA signal to external monitor, and there is Ethernet facility, and you can use a free software, PowerMax software to capture the data, or you can visualize the monitor of the power meter in the software and to control the instrument. So in the 2430A, it is a fully fused general purpose power meter, which is ideal for CW signals. And there is an optional to battery also, where you can use the battery to operate it, and you can use continuously up to 6 hours. So it is using a power suite software. You can control the ML2430A, which is used for a data logging and plots for a future analysis. So this is the 24 instrument which it looks like it is a monochrome display, and this is a color display, and it is dedicated for a CW measurements, and this is for a fast pulse measurements. So these are diode power sensors. We are having a diode power standard diode power sensors up to 10 megahertz to 18 and 10 megahertz to 20, 32, 40, and 50 gigahertz with a minus 70 to 20 plus 20 dBm CW mode. And we are having high accuracy diode sensors from 10 megahertz to 18, 40, and 50 gigahertz, which does 67 to plus 20 dBm CW mode, and pulse mode up to minus 40, minus 34 to plus 20 dBm. And universal power sensors from 10 megahertz to 18 gigahertz, wideband power sensors, which is used for a modulation and a pulse measurement, minus 60 to 20 CW mode, and minus 30 to 20 the pulse or modulated mode. So we are having dedicated pulse sensors, which starts from 300 megahertz to 40 gigahertz, minus 22 plus 20 dBm, and thermal sensors, so minus 30 dBm to plus 20 dBm, the CW measurements. So what is why we are using the benchtop versus USB? So when you come for a benchtop, it is a built-in screen, flexible sensor options, and you may want to, it is used for additional softwares and latest innovations, and for a lower overall price, small form factor, and PC interface, no 50 megahertz cal reference is required for a USB power sensor. For a USB, the benchtop power sensor smaller interface and less portable compared to the USB. So these are the USB power sensors, true RMS measurements over 63 dB dynamic range, and we are having a easy to connect to PC, no need of a reference calibrator, lightweight, and you can take it for anywhere, wherever you need. You can connect it to your PC and you can do the measurements. So these are the USB power sensors. We are having a 0.05 megahertz to kilo, 0.05 gigahertz, 50 mega. 0.05 gigahertz to 6 gigahertz inline power sensor, and we are having a 0.35 to 4 gigahertz, and we are having up to 0.1 to 50 gigahertz of a USB power sensor recently launched, and it goes up to minus 72 plus 20 dBm CW average power with a measurement accuracy of 0.18 dB. So this is an inline power sensor which is used for a measurement of a forward and reverse power measurements. Like reverse power measurements means VSWR, return loss, and reflection coefficient, which will be used for the base station and mobile communication for applications. So this is the Power Expert software which is used to do the interface between the power meter and the PC, and we can do the scope mode and time slot mode where you can get the power sustain measurements also, and you can log the data. So this is about the USB power sensors. And if you are having a handheld instrument, if you are purchasing a 19 option, you can use the same handheld instrument as a power meter, and you connect your our USB power sensors. The power measurement is limited depending on the USB power sensor frequency range and the power of the USB power sensor, not to the handheld instrument. So we are having a peak power sensors also, which goes from 6 gigahertz, 18 gigahertz, and 40 gigahertz models with up to 195 megahertz of video bandwidth, 3 nanosecond rise time, 1 lakh measurements per second, and 100 megasamples per second continuous, and 10 gigasamples per second effective sampling, which is used for a pulse profiling, crest factor, CCDF, and statistical measurements also. So it is a real-time measurement for no gaps in measurements, and capture pulses as near as 10 nanoseconds, which is used for most of the WLAN and modulation and radar signal measurements. So this is about the video bandwidth. We are having up to 195 and 50 megahertz to 40 gigahertz. We are at peak power sensors. So this is about the video bandwidth. I already explained. When the VW is too low, we cannot be able to measure the modulator signal. When there is a high bandwidth video bandwidth sensor, we can measure the modulator signal, which will be false inside the video bandwidth. So features, broad frequency range, and it can connect the power sensor. Peak power analyzer software can connect up to 8 sensors and up to 4 channels per sensor we can measure, and it can display the simple peak average power trace view for a pulse power analysis and CDF graphs. So we are having one more model called a Power Master, which is nothing but the it will be in the between the power meters and the spectrum analyzer features. So it is up to 9 kilohertz to 70 gigahertz, 110 gigahertz, and measurement range from minus 90 to plus 10 dBm. And that is the size of our smartphones, where you can connect direct to your PC and you can do the measurements. And it uses a NLTL nonlinear transmission line receiver to detect RF signal, and 70 it goes from because of this NLTL technology, we are able to achieve from 70 gigahertz to 70 gigahertz and 110 gigahertz, and it is having a wider dynamic range from minus 90 to plus 10 dBm. So what is the frequency selectivity? As you when you take a power sensor, it will be having the 10 megahertz to 50 gigahertz, suppose. So it will cover all the frequency throughout frequency range, and it will give the average power of that frequency range. When you come for the power selective power measurement, frequency selective power measurement in Power Master, you can set the frequency range from 10 megahertz to 1 gigahertz between that, and you can measure the power of that particular frequency range. There is a frequency selective option. So it is a low power capability, ultra portable kind of thing, which is can carry anywhere, and there is a wide frequency range from 9 kilohertz to 70 and 110 gigahertz. So it can be mounted to tripods, extenders, bleed clips, etc. to do the measurements, and it can be mounted for mounting holes will be there for on wafer testing. So it is a 0.1 ppm, the frequency accuracy and amplitude accuracy. Typically, it will get plus or minus 1 dB throughout the range, and the PC requirements should be quad-core i5 CPU and Windows 7 or higher also you can use, and 8 GB RAM, and it operates in USB 3. So this is the software where there will be a CW mode where you can set the CW frequency and you can measure what is the power of that particular frequency. And there is a measurement mode where you can set a channel power, and there is a power hunter mode where you can set a user can define a frequency range for the measurement with a span, and he can measure up to the power identifies up to 6 highest CW peaks corresponding to frequency you can see in the table once he sets a start and stop frequency. So there is a channel power where he has to enter what is the span of the particular channels. Like that, he can enter up to 6 center frequency to monitor, and Power Master will provide all the reading of 6 center frequencies with a span of 20 megahertz. So these applications, it is used for a post-production quality check of the tabs, mobiles, wireless communications with the different frequency ranges, and it is used for on-wafer testing, for EMI chamber leakage, over-the-air testing, and antenna installation, if there is any leakage in the antennas thing. And it is one of the use, like I told, it is used for a tab also, tab or a mobile for testing the individual frequencies and monitor multiple antennas. That's it from my side for power measurements. Thank you. So if there is any questions, please let me know. Any questions?
Okay. I don't see any question in the chat also.
Yeah, so we are not having any questions. So anyway, kindly share your email ID. I think yesterday we have given already. So all the attendees who are having any questions, you can directly reach out to either Sadananda, Aditya, Anup or Lakshmi Narayana, and they will be more than happy to respond to you. And thank you very much again, all the Anritsu team, as well as I can see still we are having close to 46 participants even after 1.5 hours of this interviewing session, which was very wonderful, wonderfully conducted by all the three speakers, Mr. Aditya, Mr. Anup, and Mr. Lakshmi Narayana. And as always, Sadanand was taking care of all the questions, but questions are not there. So I think he could not get a chance today. But no problem. We will see that if we can do this again at the end of this year, by end of this year. So I know whenever I have gone for Anritsu for any kind of support, we have already got every time. So thank you very much. And Sadanandji, please convey my regards to our Srinivas sir also. That
yeah, he's also here only.
oh, he is here, huh? Where I could not see him. Oh,
Yeah,
okay,
he's
okay.
here only. I just saw him, like he was here only. Okay. Anyway.
Okay. So please convey my regard to him and tell that IEEE Bangalore section is really thankful for his all the supports throughout so many years which we are getting. And thank you very much to all of you. Thank you.
Yeah, thank you very much, sir.